Hi everyone, this is the Algebra 1A Semester 1 exam review, and this will be the Chapter 3 portion on linear functions. This first video will cover probably the first page front and back, which means we'll go up through question number 9, and then I'll pick up with the rest of it in subsequent videos. So, number 1 is really just about reading information off this graph. So this is representing Corey traveling from her cousin's house to her grandmother's house and then back to her own house. Okay, so we can assume this is where the cousin lived. This flat area represents where she stayed in one place for a while. I'm going to assume that's good old grandma's house, and then this is where she heads back home. So how far from home did Corey start? Any questions that are asking how far are looking for a distance, so I'm looking along the y-axis. So how far from home would be represented by this distance here, because the 0 represents home. This looks like it's counting by 10, so I would say that's 30 miles from home. Okay. How fast did Corey travel during the first 2 hours? How fast is asking for a speed. And speed is always a distance divided by a time. Think like miles per hour, okay? So you can measure speed in all sorts of different units. You're probably most used to hearing miles per hour, but that is a distance divided by a time. So we know the time, right? We know the time is going to be 2 hours. And so I am looking at the portion of the graph. Let's see, here's my 2 hours. I'm going to end up scribbling all over this thing before we're done. I'm looking from here to here. And this is the portion of the graph I really want to focus on for those 2 hours. And the distance that I traveled, let's see, that's starting at 30 miles and going up to, oh gosh, I hope I'm reading this correctly, 100 miles. Okay. So from 30 to 100, that's 70 miles total. Divided by 2 hours, that's 35 miles per hour. My gosh, that sounds brutal to travel at 35 for 2 hours, but that's what the graph is telling us. Okay, and then what was the total distance that Corey traveled? Well, she went from 30 miles up to, this looks like 120 miles. So from 30 to 120, that represents 90 miles. And then she went from 120 miles all the way back home, so that would be 120 back to 0, represents a distance of 120 miles. And so the total there is 210 miles. Okay. Which again, just for reference, that would typically be about a 3 to 4 hour drive. And this apparently took her 8 hours because she is traveling at a speed of 35 miles per hour. But anyway, that's a conversation for another day. Okay, let's take a look at number 2. A scuba diver is 40 meters below the surface. The diver ascends at a constant rate of 0.8 meters per second. Give an equation describing the relationship between the depth and time. Okay, there are 2 ways you can interpret this question. And I would say either one of them is correct. But if there were a follow-up question where you had to plug a number in, you would just have to pay attention to how you interpreted it the first time. So my instinct is to say that if I'm 40 meters below the surface, that's really a negative 40. Okay? So I would say that my depth is starting at negative 40, but that it's increasing. I'm heading upward because I'm ascending, so that's positive. So below means negative. You're not going to be able to see that anyway. Ascending is positive. I'm ascending at a rate of 0.8 meters per second. Okay. Oh, sorry. I didn't mean to use an M. I want to use an S. Okay. So this is one answer that would work perfectly well. However, I could see you making the argument that since we're calling this a depth, that we should just be able to say the depth is 40 and know that that's 40 meters below the surface. So if you started with a positive 40, that's all fine and good. But if you started with a positive 40 as your depth and you're heading upwards, technically your depth is decreasing. So you would do minus 0.8 per second. Okay, because that's what's happening to your depth, is that if you're coming upward, your depth is getting smaller. Okay, so I would actually take either one of these as a correct answer to this question. Okay, they're not the same mathematically. What would really have to change here is how you plug your number in. You know, if it wanted to know how deep are you, and I guess it wouldn't matter so much how you plug the number in, but how you interpret the answer that you get. But a question I could see being asked is, you know, how deep are you after 3 seconds, let's say. So you would plug in a 3. In this one, you're probably going to get a negative answer. You would just have to know that that represents a depth. This one, you would get a positive answer. You would still have to know that that represents distance below the surface. Okay, 3 and 4 are just working on graphing, but they are equations written in 2 different forms. So let's start with this one. This is in y equals mx plus b form. So I always start at the y-intercept, which is 2. So this is where I start. So I'm going to go to 2 on the y-axis. By the way, you are always starting on the y-axis. Always. We're never starting on x. And then my slope is my m, and that tells me where to go. And notice that I could take that 4 and really write it as 4 over 1. So that tells me to go up 4 and to the right 1. Rise over run. So you're always going up and down first before you go left and right. So I'm going up 4 and over 1. I can fit it in there again, up 4 and over 1. Remember, if I really wanted to, I could also go down 4 into the left 1. That's all going to give me the same line. Okay, and that's it. I graphed my line. So now looking at number 4, it's asking me to graph, but this one is in what's called standard form. Now, if I really wanted to, I could solve it for y, and that would turn it into an equation like this one, and then I could do it exactly the same way. But I usually use a shortcut here where I just look for the intercepts. Remember that at the x-intercept, just want to write this down so you see what I'm talking about, the y is equal to 0, okay? So if I want the x-intercept, I can cover up the y value. Oh, you're not going to be able to see that. I can cover up the y value, and I have 6x equals 42. So then x would equal 7. And that means I know that this graph is going to cross at x equals 7. And then I can do the same thing with the y-intercept. I can say at the y-intercept, I know that x equals 0. So I would cover up my x. That gives me 7y equals 42. And when I solve that, I get y equals 6. By the way, these are things that I normally don't write down. I'm writing them down so you can see what I'm doing. But these are normally things where I can just kind of cover one up and solve for the other one. Okay, especially if they're easy numbers like this. Y-intercept would be at 6. And then I can connect my 2 dots, and voila, I have my line. Okay, let's go on to whatever's coming up next. Some more graphing. Okay, this one, I know that's a little bit hard to see. I'm just going to rewrite here. This says 3x equals 2y minus 12. At least I think so. Yeah, pretty sure that's 3x equals 2y minus 12. Well, the problem with this one is it's not in either one of the forms that I'm used to. What I would probably do, and I guess this is going to make it be the same as if I interpreted that differently, I would move this around to be in standard form. I could move it around to slope-intercept form, but it's going to be quicker to get it in standard. I'm just going to subtract 2y from each side. And so this side I'm just going to write, I can't actually subtract those, so I would write it as 3x minus 2y equals negative 12. And then I'm going to do exactly the same thing I did in the last problem. So I'm going to look for the x-intercept by covering up the y. 3x equals negative 12, so x would equal negative 4. Just jot this down. 3x equals negative 12, which means x equals negative 4. And then I'm going to cover up the x, so I have negative 2y equals negative 12, which means y equals positive 6. So y, 1, 2, 3, 4, 5, 6. And graph your line and you're good to go. Okay, number 6. I'm going to do a similar thing to what I did here. You'll notice that you only have a y here, so if you solve that for y, you get y equals negative 2. Anytime you only have a y, that's going to give you a horizontal line. And I know that comes up later in this packet, but if you don't know that, you're really going to want to make sure you study that. When do you have a horizontal line? When do you have a vertical line? Y equals is always a horizontal, and this would be a horizontal at negative 2. So I'm just going to have a line going straight through like that. Okay, let's carry on. And when I said later in the packet, I didn't realize that I meant the next question. So consider the line with the equation y equals negative 2, which is actually what we just looked at. Okay, this is exactly this problem. What is the slope of this line? A horizontal line is flat, so it's always going to have a slope of 0. Okay, horizontal lines always have a slope of 0. What is the y-intercept of the line? Y-intercept is negative 2. Okay, consider this equation, and this one is in mx plus b form, so I have my m, I have my b. That might be helpful in a minute. What is the slope of the line? Well, the slope is just the m value, so it would be 5 over 6. What is the x and the y-intercept of the line? Well, the y-intercept is easy because it's just sitting there for you, right? So I'm going to start with that. The y-intercept just comes from the fact that b is equal to negative 10. Okay, so that's your y-intercept is negative 10. The x-intercept is what gets everybody. And technically I could have found the y-intercept the same way, but because we know this formula, we can usually pick out the y-intercept pretty easily. At the x-intercept, we always know y is equal to 0. Okay, so what I have to do to find my x-intercept is make the y equal 0. So I'm going to say 0 equals 5, 6x minus 10. I'm going to take some shortcuts here. Move the 10 to the other side, so I get 10 equals 5 over 6x. Okay, and then to get rid of that 5 over 6, I would multiply by the reciprocal. And let's see, that's going to give me 12, I believe. So x equals 12. Now, really, back here, I could do the exact same thing but opposite. So at the y-intercept, x would be 0. That would have left me putting in a 0 here, which would have canceled out this entire thing, and I would have been left with just a negative 10. Okay, so I could have done that same thing. You just sort of have a shortcut when it's a y-intercept and it's in that form. Okay, so again, y equals 3x plus 4. Slope of the line would just come from right here, so m equals 3. What is the x-intercept? And again, at the x-intercept, make y a 0. Okay, so I'm going to say 0 equals 3x plus 4. Subtract the 4 from the other side, so negative 4 equals 3x. And then divide by my 3, divide by 3, divide by 3. And I end up with x equals negative 4/3. Okay. Okay, that does it for this page. I will pick up with another video in just a few minutes on the next page.